who grew up, studied, and started his career in this academic community. He is an agricultural economist, a consultant of this division, and associate professor at the North Carolina State University. Our speaker could have been one of the lawyers in Philippine courts today, or even a member of the defense or prosecution lawyers of the impeachment court impeaching the Chief Justice of the Philippines. After completing his bachelor's degree in agricultural economics, he wanted to be either a lawyer or an economist all the way. And obviously, he chose the latter. He left for graduate studies in the US. He took up MS in agricultural economics at Clemson University and PhD in agricultural economics at the University of Illinois in Urbana-Champaign. But he also took an MD, a marriage degree. While taking up his PhD, he met his beautiful wife, who is a Filipino nurse, and consequently settled down in the US, raised a family with currently 3 young children. 2 boys and 1 girl. Our speaker is a prolific writer and very generous in sharing his knowledge, as many of us were beneficiaries of his generosity. This was demonstrated when he conducted a training on econometrics for impact assessments to SSD staff, including UPLB students. This morning, he's going to talk to us about long-run time series analysis of global rice consumption through 2050. So ladies and gentlemen, let us all welcome Dr. Roderick. Rejesus.
Thank you, Flora, for the nice introduction. Appreciate the opportunity to sort of share what I've been doing for the past couple of months here at IRRI. And this is sort of pretty much a work in progress. So if you have any comments, suggestions as I go forward through the presentation, just raise your hands. You don't need to wait for like the last 15 minutes for questions. So if you have any burning questions as I'm going, just raise your hands and we'll try to address it right there. Okay, but we'll have, I hope to finish it in 45 minutes, and so we'll have a little bit of time for questions afterwards as well. Okay, so let's just go straight to this presentation. This is work by myself, Sam, and Joe Balarta. So Joe will answer the hard questions for me if you guys have hard questions. All right. Okay, so this is a graph of aggregate global consumption. Okay, so it increased from 1960 to 2011 from 150 million tons to 450 million tons. And I call this sort of a green revolution spurred consumption because with increases in production due to the green revolution, this amount of consumption became possible. Okay, so increases in production makes increases in consumption possible. So if you track, in essence, production, it will look very similar. It will track consumption. Okay? Now that's sort of an important concept that I want you sort of to think about, that consumption is tied to production. All right. So for example, you can't just look at consumption data in a vacuum and say that it's consumption because it's tied to production. So for example, a lot of economists here supply and demand, there's simultaneity in supply and demand, right? So that's sort of the same thing. Consumption and production is linked together through prices, through markets. Now looking at just the per capita rice consumption, it also increased, but it sort of leveled off in the 90s. It sort of peaked in 2000 from 48 kilograms in 60, 66 kilograms in 2000. It sort of hovered around that 65 kilogram range since 1990 onwards. Okay, and this is sort of the picture that a lot of folks in this literature really sort of focus on. They sort of look at this plateauing here, and it's also the decline in the mid-2000s as sort of They interpret that as a decline in demand per se. Okay? So because of that sort of leveling off and a little bit of decline in mid-2000, it sort of upticked in the last 2 years. But again, remember sort of the link between production and consumption. That may be one interpretation, but as we see it, it's a more complex story. You could interpret that sort of flattening out as population growth outpacing production, meaning demand outpacing supply. Okay, and that will result also in sort of a flattening out. Okay, and so if demand outpaces supply, what will happen to prices? It increases, right? So there's effects on price levels and welfare, and therefore, for example, we saw that in 07, 08, production was way below demand, stocks was low as well, prices spiked. Okay, so the levels of production and consumption have important effects on price levels, on welfare, and therefore it has very important implications for the poor and for food security. Okay? And this sort of dynamics is the one main reason for getting a handle on how consumption and production would need to evolve over time, right? So if governments, donors, the producers themselves, and so forth, get a handle on this consumption trends in the future and production trends in the future, that would be helpful for setting policy, making research investment decisions for donors, etc. And that last part is especially important, as Randy was saying, for IRRI, because these types of things are what donors look for, and sort of they base their decisions on some of these trends in consumption and production. Okay. So, given that short introduction, we want to look at this literature that forecasted and predict global rice consumption. Okay, and we briefly look at and examine some of the limitations and some of the concerns that we have for using global rice consumption per se for making forecasts. Okay, but even we will have issues with that, but nevertheless, given that it's sort of being used in the literature and being used by a lot of authors, we take that as a given in this paper and focus on the time series properties of these forecast models. Most of the time, studies that forecast global consumption use time series, variable time series models to project and predict future consumption. Okay? So we take that as a given, even though we identify some limitations, and focus on the time series properties of it, and then try to develop and sort of evaluate forecast performance of alternative models, assuming the previous models that have been used are not very good. Okay, so that's what we want to sort of show in this paper. And so let's look at this first objective first. I'm going to give a brief overview of the literature in this area. So as I've said, most of the studies out there use aggregate data, whether it be global or country level consumption data at the aggregate. Okay, and it's time series, so 1960 to whatever, 2011, 2010, and as I've said, it's being utilized for public policy decisions. Okay, most of the studies predict consumption to fall. Okay, so it pretty much sort of takes that plateauing in that per capita graph and sort of builds stories behind that. Is the thread of the literature right now. Okay, and one prominent paper is this paper by Timmer that was published in a book published by IRRI actually, and he predicts a 360 million ton consumption levels by 2050. Okay, so it will drop. Right now it's around 450. So he predicts a drop in 2050 to 360 million tons. Okay, so it's sort of, I'll show a graph in a little bit. Abdullah is another recent study. It's less complex than Timmer, but he also has a couple of scenarios, and this one scenario in particular predicts a decline as well to 383 million tons. Okay? I'm highlighting this too, but there's also other studies that predicts, like SEC and Mark Gross grant at IFPRI predicts an increasing trend. So there's a mixture, but this is sort of the prominent study right now. And for example, last week Timmer presented in the Philippine DA, and he's sort of presented his work. Okay. And as I said, these studies sort of latch on to that plateauing and even a decline in per capita consumption in the mid-2000s. And their explanation behind that is this. Okay? There's declining income elasticities. People, as income rises, substitute high-value foods for rice. Consumption of rice declines. Okay? But again, this is sort of looking at that graph in a vacuum without thinking about the production side of things. Okay? And they often cite Sam's advisor, Ito Peterson. Peterson is Sam's advisor. This 1989 AJ8 paper that showed in Japan and some other wealthy countries flipping of the income elasticities from positive to negative. Okay? Using time series data as well. And this, as I said, they use this sort of regression at the aggregate level to capture this sort of relationship. So consumption as a function of per capita GDP is your proxy for income. Okay, so they regress that, show, estimate the parameters, and then forecast based on this. Okay, and that's exactly what Timmer did. Okay, so that's what's been done. And this is the graph of Timmer, okay, based on that main concept. So he expects, because of income growth, consumption will increase around gradually till 2025, and then it'll drop. That's his story. Okay, and this is at the global level. All right. And again, notice here his confidence intervals are narrow. He's very confident about his point estimates, and we have issues with that as well. Okay. So what's the problem then? What's the problem? It's a nice story, it's easily understandable, but what's the problem? What are the limitations of not just Timmer's work, but all the other work that uses global rice consumption time series for making projections, including ours, including this paper that we're presenting? It's still a problem. First, previous studies are relying on that assumption that income elasticities are negative, or are gonna be negative as income increases. But the literature says that's not really the case. Okay? A lot of the studies that shows negative income elasticities are time series papers. Even in Japan, there is another paper using cross-section data that says it's not negative. It's positive. So the implication of this is there's got to be a little bit more work on this issue of whether income elasticities are really negative or positive, and maybe, and I'll touch on this in the end, that maybe a panel data type analysis would be more appropriate in this case. Okay? Because typically people say that time series, you underestimate, cross-section, you overestimate. That's why these things are, there's a debate. The other thing, again, is going back to that production-consumption linkages. Okay? When you use that global consumption data, typically it's an availability or residual concept. Consumption is calculated as a function of production less net stocks less net trade. Okay? So it's essentially, again, there's this simultaneity issue between production and consumption, and in sort of the econometrics world, if there's this simultaneity and you just estimate one side of the equation, your demand parameters that you estimate, your income elasticities, will not be identified. Okay, you're capturing something else if you don't take account of the consumption-production linkages. Okay. Another problem is with aggregate data in particular is the heterogeneity in behavior. Okay. Timber, for example, uses global consumption. We use that as well, but it masks a lot of the heterogeneity in behavior. Okay. So difference in countries. A lot of the previous studies sort of point to Japan, Korea, Taiwan, saying that everybody else will behave like Japan, Korea, and Taiwan in the future. That's why consumption will go down. But that's sort of a little bit naive. It depends. Philippines income is going up. Rice consumption is still going up. So, it depends. And then there's this issue of different varieties, high quality versus low quality rice. Will behavior change? Of course, you think that if it's a higher quality rice, there's got to be some substitution as well from low quality rice to good quality rice as income grows. Okay, so that's the other thing that we want to sort of highlight as problems with using global or aggregate type data. But even with these limitations, as I've said, aggregate data is being used. It's being used by donors. It's being used by researchers. But still, taking that as a given, a lot of the previous studies do not take care of some of the time series properties of the data. Okay. For example, as I said, they estimate a rice consumption GDP relationship, but for this relationship to hold, the time series has to be stationary. Okay? In sort of the parlance of the time series econometrics, there has to be no unit roots. Okay? That's sort of when you go in your first day of your time series econometrics class. This is what they teach you. Okay, this is what they teach you. You have to check for unit roots, because if there's unit roots, that means you can't just simply use a simple algebraic model based on time series data, because the data is not stable, in essence. If this is the case, based on sort of the classic paper by Granger and Newbold, this is what they call the spurious regression phenomenon. Okay? You're getting some relationship that's not really there, and so really, for example, in our context, GDP per capita, if there's unit roots in GDP and consumption, it's meaningless. GDP cannot be used for forecasting in this case, okay? Except for an exception, which I'll discuss in a little bit, right? Questions so far? Are we good? Okay. So data that we're using. As I said, we're taking sort of the aggregate data as a given, and I think Josie is not here, but I thank Josie for helping me get the data for this paper. So we used also the global rice consumption data, USDA. As I've said, this is sort of the definition, I guess, of the consumption. So you calculate consumption based on production, less stocks, less trade. Okay. So again, there's a link, right? That's problematic, as I said. But we'll take that aside for the moment. Okay. So this is sort of the main variable that we look at. And then I emailed Peter Timmer and Block and David Daw, and they sent their data as well. And I updated it using, again, Josie helped me find new data to update their data sets as well. Okay, so I used their GDP, their population, their export prices, and so forth, that they use in their model. Okay? And so, as I said, the first step then that we want to look at, given the time series nature of this data, is unit roots. Okay? Again, time series has to be stationary, and stationary implies no unit roots. It allows for a stable relation over time. If it is, then you could use your OLS regression for estimation. Okay? If not, as I said, there's spurious regressions. The typical sort of symptoms of this is you'll get high R-squared, high T statistics, but there's really no economic or causal interpretation. The way I think about it is, for example, if GDP and consumption is like growing over time, okay, you'll get high R squared, you'll get high statistics, but doesn't mean that one causes the other. That's the problem if it's not stationary. And it's the same with all other time series variables. That's why it has to be a stationary. That's why you have to test for unit roots. Okay, that's the idea. And then there's several tests that have been developed over time. Of course, the classic test is the Dickey-Fuller, developed by David Dickey when he was at Iowa State, PhD student. He's now at NC State. Wayne Fuller is his advisor. So, and then a lot of people worked with this test and improved it. So there's the ADF-GLS, Phillips-Perron, and the KPSS test as well. So we use all these tests to see if there's unit roots in rice consumption and GDP per capita. So let's look at the first three tests first. Augmented Dickey-Fuller, ADF-GLS, and Phillips-Perron. The null hypothesis in this test is that there's unit roots, okay? Meaning it's non-stationary. So the test statistics are all below the critical value. You fail to reject the null, therefore what? There is unit roots, right? So that's sort of the, well, you don't say that. You fail to reject the null, that there's unit roots. But there's unit roots, is essentially the conclusion. The KPSS test is sort of a better test in the sense that the null is the other way around. There is no unit root, so if you, the t statistics is greater, you reject the null, there's no unit roots, so there is unit roots in essence. Okay. So this shows that per capita rice consumption and GDP per capita have unit roots, they're not stationary. Okay, that's the problem. So, now, as I said, if there's unit roots, there could be spurious regression, except there's one exception. There's one exception. If the two variables are co-integrated, then you can still use your OLS estimates. So you have to test for co-integration as well in time series. In this case, co-integration means that there's a parameter that makes the linear combination of consumption and GDP stationary. In that case, the regression is the two variables are co-integrated. The parameter estimates are is super consistent long-run equilibrium. Okay, so if that's the case, if they're co-integrated, you could use ECM, error correction models, and so forth to look at long-run, short-run behavior of variables. And so there's a couple of tests that we use, Engel-Granger and Johansson integration tests. And the null is that there's no co-integration. So this is smaller than the critical value. So there is no co-integration. So the results of no unit roots with no co-integration, unit roots rather, with no co-integration means if you regress consumption on GDP, it's spurious, in essence. All right? That's the main conclusion coming out of these tests. So if that's the case, then you can't use what Timmer used. You can't just regress OLS and use the parameters to project. Okay? And I just wanted to show you, again, I'm not picking on Timmer, but I guess I'm picking on Timmer a little bit. Looking at his regression models here. Okay? As I said, the classic symptoms of spurious regression, high t statistics, high R squared. Look at that. This is again log rice consumption, log GDP. Right, very significant. R squared, very high. So this is sort of a classic symptom of spurious regression. Yes.
I have a question regarding the unit root test.
Okay.
Maybe does it also depend on the number of lag years?
No, because
That's
it's
not one lag in the unit.
yeah, you could. I checked that. I had like 5 lags. It's still the same. So the one I presented here is just 1 lag. Okay, it's just 1 lag. 1 lag for this, and the others there's no lag. But I checked with the Dickey-Fuller for 5 lags. It's still there.
Maybe it's more than 5 lags.
No, they did it, right? Look. So it's just GDP per capita and log GDP per capita squared.
But I mean, should we worry very much about it at the beginning? We can determine the appropriate number of land and then just specify it. I mean, using AIC and SIC.
You could do that, yeah.
Just specify the appropriate one.
Yeah,
At the beginning, yeah.
but still, I guess it doesn't get away from the fact that it has unit roots regardless of how many lags you include.
Yeah, I mean, I always double check also. I mean, going for further lag and see if
Yeah.
can change it.
Yeah. So there's none in this particular. There's still unit roots. Yes.
The previous slide is test score. You said that it's the null hypothesis is not rejected because the t-test is greater than
Smaller.
Smaller than. So it should be, I think, absolute value because 2.02 is greater than 2 points.
Yeah, it's absolute value. That's what I meant. I'm sorry. Yeah, that's what I meant by it. It's gotta be absolute value. Correct. Other questions?
No, could I just,
Okay.
you're using, all the time you're using global data.
Yes. Global rice consumption data and then GDP.
That's all I want to know.
Yes. So we're taking it as a given.
I don't think that makes much sense, but go ahead.
That's right. We say that too. But that's what's being used.
One way to interpret that what's been presented so far is that if you use exactly the data that Timmer and Block and Daw use, but you're careful about how you use it and you deal with the time series properties appropriately, you'll come up with different results if you use their data.
Yeah, and my point is, you'll come up with different results, but should I believe you?
Not
To
really.
the,
No,
to the extent
of course
that
Not really.
No, I don't think so, because I don't, your assumption is, you started off by saying, gee, countries are different, people behave differently in each country, and then you all of a sudden, you put all the countries together.
We anticipate
It's
that the
crazy.
reviewer will say that. Yes, that's why we're saying that we have problems with it up front, but people still do it, and how can we improve it given that people
Oh
do
my
it? So
God.
that's sort of how we sort of
Look,
think about it first.
that's not the right answer.
Well,
No, the fact is that this data is used to inform policy questions,
Yes.
right?
But
And
but
so
you
let's-
want to
let's-
prove
let's-
that it's wrong.
But starting there,
And you start with country data to show that it's wrong.
that's our next step. You're
I
getting our
think
punchline,
you're-
Randy.
I think you're exactly right.
That's our punchline in the end.
if you
That's the punchline.
start if you start with this, the thing is, if you start with their data and say, okay, you want to use this data, we think there's problems, but if you want to use it, let's do it right and see what we find, right?
Do it right.
And then we're gonna address your problem.
You know, you do it right. I don't have to see you do it right,
I
because I won't
I've
believe what
I've
you've
been
got.
with you for a month
Okay.
now, and I haven't seen you find any analysis that's done right. And so that's a problem, Randy. If everybody's
Okay,
all wrong, right? If nobody's doing anything right, then we're not getting
So
anywhere.
not technical.
I'm just asking you
That's
to
just-
think.
I think we agree actually on this.
Yeah, all right.
So, okay, can we move on now?
Can we move on? Coffee.
All right. So, okay, again, we're taking it as a given. We're taking it as a given for now, and to see how we can improve it, given that people use it. Okay, and given that there's unit roots, there's co-integration. One way to take care of it is first differencing. Okay, your first difference consumption, your first difference GDP, and see how the relationship, whether it's significant or not. If it's significant, then you could use the parameters for forecasting purposes. If not, then alternative approaches need to be used. Okay, so univariate time series approaches in particular need to be used. Okay, and so we did this, and nothing. There's nothing that's significant. Okay, these are p-values in parentheses. They're big. Nothing is significant. That means using a Timmer type model where you use GDP per capita to predict consumption is not helpful if you take care again of the time series properties by first differencing. Okay? So given that, then you have to sort of go back and use univariate approaches for forecasting. And there are three approaches that we use: the IRRI models, double exponential, and Holt-Winters smoothing methods. So that's the things that we evaluate in this paper, trying to improve upon what previous studies have looked at. Okay. So IRRI models, in essence, and in univariate approaches in general, use lag values to explain current values. Okay. So the very basic model is sort of the autoregressive AR1. 1 means just the number of lags you use. You can go AR2, 3, 4, 5, 6, whatever. If you have a moving average ARMA, you could do a moving average lags as well on the residuals. And the more general approach is sort of an ARIMA type model where it's autoregressive integrated moving average, where you could difference the variables as well. Okay, so AR1 is equivalent to ARIMA 100, R11 equivalent to ARIMA 101. So that's sort of what we're doing here. And the problem is, or sort of the practical issue in ARIMA models, is how to pick your lags in Y and lags in the error term. Okay? The D is the number of differencing. Typically, if you first difference, you take care of stationarity. So D is typically 1. Okay? So the problem is either P or Q. Okay? And I'm not going to discuss sort of the approaches that we use in detail, but we came up using sort of the Box-Jenkins method and sort of successive AR evaluation. We find that these two models, ARIMA models, would probably be best candidates for forecasting rice consumption using univariate approaches. Okay? So we ran that model. We compared ARIMA and ARIMA 213. The problem with ARIMA 213 is you see it's only the moving average term that's significant. But in the AR1, it's strongly significant, so we thought that we'll just go with this one. It's more parsimonious, more straightforward. Lag values of Y explain future values, or current values of Y. So we don't evaluate this, we evaluate an ARIMA 110. Okay? So that's one model, one forecast model. Then we look at smoothing methods. Well, exponential smoothing, there are three types: single exponential, double exponential, and Holt-Winters. Okay? The concept here is more recent observations are given more weight than older observations. And there's an inherent differencing already in these smoothing methods that takes care of this stationarity or unit root issues. Now, we could have looked at all three, but there's a limitation for single exponential. It only gives a single value forecast, so it's just a constant irregardless of what your forecast horizon is. So if you have trends, as we can see, our data up front has trends. This is not sort of advisable a priori, so we sort of discounted single exponential. So we eventually just focus on double exponential in Holt-Winters. I'm not going to go through it in detail, except that this is sort of the formula that it's being used for exponential smoothing. In this case, the intercept term is sort of constant, and the slope term sort of determines the drift, the trend. Okay? Holt-Winters is sort of a more general approach that accounts for seasonality, but I did not consider seasonality here because the graph doesn't support seasonality. Okay, so we didn't consider that, except it's more general because the slope and the intercept sort of makes the series drift. Okay, so A in this case drift compared to double exponential, it doesn't drift. Okay? It's more general. But it doesn't mean it's better out of sample, okay, or for forecasting. So those are the three models we looked at, and sort of this is the parameters we got. And the way you sort of interpret the parameters here, it's not close to 1, the alpha. So the effect of older observation doesn't go away fast. That's what it means. Okay, so older observation still has influence on the current observations, or the forecast, sorry. Okay, now given those three forecasting models, then the question is, which one do we use for forecasting global rice consumption? And you have to evaluate it out of sample. So what we did is we split the sample. So for example, if you want to look at a 10-year horizon and you have 50 years of data, and you use 40 years to estimate your parameters, then 10 years to evaluate the forecast, whether it's close to the truth or not. And there are several criteria to use: root mean squared error and mean absolute error, where E here is sort of the error when you compare the true value and the forecast value for the sample that you split up. Okay? And we use it for 5 years, 10-year, 20-year horizons, forecast horizons. Of course, you pick the RMSE and MAE that are lowest, right? Because you want the lowest error. You pick the model with the lowest error. Okay? The problem with that is how small is small. I mean, it could be that the RMSE is 1 for one model, it's 1.002. So you pick the one with 1, but are they significantly different? Is the question. So that's where this test by Diebold and Mariano comes in, where you can test whether the difference between the errors are significantly different. Okay, so that's what we use for evaluating out of sample. And so as I said, we use 5-year, 10-year, 20-year forecast horizons. For a 5-year forecast horizon, the ARIMA 110 has the lowest RMSE MAE, right? For the 10 and 20, it's the double exponential smoothing. So if you're just thinking about a 5-year forecast, maybe an ARIMA 110 would be better, it's preferred. But since we're wanting sort of a 2050 forecast, we want sort of a longer term forecast, so the double exponential seems to be the preferred model in this case. Okay? And it's the same thing with the Diebold-Mariano. Diebold-Mariano is sort of a pairwise thing, so by transitivity, Holt winners is preferred over double exponential, ARIMA is preferred over double exponential, ARIMA preferred over Holt winners. By transitivity, ARIMA is the preferred. Okay? And it's sort of the other way around for the 10-year and 20-year horizon. Bottom line is the double exponential for a longer term, medium to longer term forecast seems to be the best performing out of sample. All right. So that's given that double exponential is what we use. Yes. Although I forecasted with all three as well, but I'm not going to present those results. So double exponential is what we use. Here's our forecast for per capita consumption with very wide forecast intervals. In this case, it's very gradual. So around 65 right now to around 67 by 2050 with very wide confidence intervals. Okay? And the confidence intervals being wide is expected because there's a lot of things could happen. There's lots of imprecision in the point forecast over time, and as time goes by, as your forecasts become longer, imprecision increases as well. Okay? And that's one thing also in the previous study, they haven't emphasized that sort of imprecision over time. They always say, this is my point for 360 million tons, whatever, 383 million tons, but they don't discuss the intervals. Okay? So again, this is per capita consumption. If you put in the aggregates, plug in the forecast for population, and population growth is expected to increase from 6 billion today to around 9 billion in the future. So there's an additional 3 billion mouths to feed that's expected. And given sort of that flat per capita consumption, you expect aggregate rice consumption to increase. Again, assuming here that production there's production available to make this consumption possible. Okay? So, and again, the confidence intervals are going to be wide. It's just the nature of the beast. Okay? And just to show you some numbers again, So for 2020, for example, it's 491. So from 450 right now to around 491 with a forecast with an interval around 100 million tons. Okay? As you go forward in time, 650 is what we're getting for 2050, but with a big interval around 300 million tons. Okay? Which I think is reasonable. And just comparing with previous studies, if you look at this 2020 forecast, all of this previous studies are within our confidence interval. It's very close. It's around 490 most of the time, but it's within our forecast interval. Okay. As you grow forward in time, it becomes more variable, right? It's all over the place by 2050. Some have 300, some have 400, some have 500. We're at 650. Okay. 2025, I guess two out of the 7 scenarios are within our confidence interval. Okay. So it's just hard inherently to forecast over time, and there's more variable forecasts as the time becomes longer. Okay. And this supports our sort of notion that as time goes by, your forecast intervals will be wide. Okay. And then we'll go back to timber. This is the graph I showed you earlier. Okay. And again, remember what timber has. Okay. So here again, we're going back to that issue that if we just take that global rice consumption as given, and timber has been taking it as a given and presenting it in various audiences, it's showing that rice consumption will go down. Just taking care with the same data that they have, as Joe was saying, we get totally opposite results. Okay, and personally, I find it hard that it'll drop that low. Okay, it's even below our forecast interval. Okay, their estimates. Okay, and maybe it's also just a function of they impose a functional form right away that forces it to drop anyway. So that's another problem. Okay. Now, one question that came about is maybe it's just your sample that you use. For timber, for example, used 61 to 2009. I used 61 to 11. So what if I use the same sample as he did? Okay. So this is what I got, 61 to 2011. If I use 61 to 09, there's a decrease in per capita consumption. But is this drop in per capita consumption sort of overtake the increase in population growth that we expect? And we don't. This is sort of what I get as well for 61 to 2009. It's still increasing. I mean, we have 3 billion mouths to feed. More mouths to feed in the future. Except it's just we're just off by 50 million tons. But the point here is that, again, when you're interpreting and taking as a given this global rice consumption data, estimation sample matters. Okay? In Timmer's model, he didn't account for the recent uptick in consumption in 2010 and 2011. So that's why it's sort of going down. But when you take into account the uptick in 2010, 2011, then you sort of, my projection is sort of a little bit flatter rather than going down. All right. So, questions so far? Because I'm gonna.
Has anybody used any kind of meta-analysis just to see what is driving those results? I mean, you just.
Well, the problem with meta-analysis, you have to have a lot of studies already, and it's not a whole lot.
I have a few there. How many did you cover? Not too much.
Yeah, but the problem though is not all of these are time series stuff. So, like for example, SEC is more of this global rice model type of deal projecting forward rather than a time series type of thing. So you have to sort of have a lot of time series papers projected, right? Yeah. Maybe by country, I don't know. I haven't looked. Okay.
But if I this graph, okay. So if you use 2000 up to 2009, so your and Timor forecasting is almost same, or
No, still different. See, this is what I get. It's still increasing. Compare that to him, which there's a drop. And this is the aggregate, though, because remember, the aggregate is a function of the per capita times population, right? My per capita will drop, is what I'm saying. But the drop in per capita doesn't overtake the increase in population growth, such that the aggregate consumption, even just through 2009, will still increase. It's just 50 million tons off, is the thing. Okay. Again, this is accounting more appropriately for the time series data. So. Other questions? Are we good on time? Yes.
I don't understand your econometrics, but I have
Neither
a
do I,
question on the assumptions in estimation of consumption. There is no question that the poor consume more than the rich. So a lot depends on what happens to poverty. If we are not moving in terms of reducing poverty, the consumption will go higher. And with the economic crisis, even the US has hunger
That's true.
now. So how long will this economic crisis last? And what is the impact of this globally? So I would take the higher consumption forecast because of this. I think we have to go back to the assumptions
Yeah.
on the estimation of consumption.
And that's where we could go back to that issue of measuring income elasticities. So if you have income elasticities for different deciles of the income, different income groups. And so
We
forth.
are not like Korea, Japan,
Correct.
and Taiwan.
But that's sort of the implicit assumption that's being done
Yes.
as well. That
So I think that assumption is to be
Correct.
dispelled.
Correct.
So why don't you go back to the
We'll get to that now. Okay, we'll get to that for future work. So, okay, so as I've said, global rice consumption is important. It's being used for making policy decisions and so forth. Given that, we wanted to sort of understand previous models, identify its limitations, and in particular, again, since global rice consumption is being taken as given, what are the time series properties and what are the alternative models? So that's the focus of this paper, and we're not promising to answer all the questions for that, but we have future work. Okay, so what we found, non-stationary, not co-integrated. Previous studies are misspecified. We think FD models that improves on these OLS models are not useful. We evaluated three univariate time series approaches. We find that the double exponential smoothing works best. We expect 650 million tons consumption, again, given that the production is there. Previous studies' forecasts tend to be below what we're saying, okay? But again, it becomes highly variable. And this is sort of the punchline that we're saying earlier, and Joe sort of elucidated on, that if you take the data as given, we know we have problems with it. Our results are opposite what has been said in the past. Okay, so that's what we're trying to focus on here. If you just take care of the time series properties, you'll get opposite results. Okay. But as we emphasized as well, there are problems. You have to take note, even in our results, you have to take note of the imprecision. You have to take note of the sensitivity to estimation sample. Take note of the heterogeneity in behavior. Okay, so we're saying per capita consumption in Philippines, Africa, USA going up, Japan, South Korea. So it's naive to generalize that it's.
How do you do that?
Well, we'll get to that. So we have limitations for aggregate consumption. As we've said, this production consumption linkages are not being taken care of. And that's where we think household level data to estimate demand parameters may be more useful. And that's where we want to sort of say, Randy, that where we want to go. If we have a panel data is preferred, but a multi-year household survey data of consumption patterns for rice, for different kinds of rice, for different kinds of food products, we could answer this question more definitively. And it overrides some of the criticisms of previous studies that just use time series or that just use cross-sections, single cross-sections. Okay? In this type of approach, we're wanting to use what they call age-type models, the almost ideal demand system type models, where you could identify, again, take care of this structural link between production and consumption, and just be able to estimate those income elasticities, own price elasticities more definitively. It'll be identified in that type of case. So that's what we were thinking, and that could answer, if we could get income elasticities per country, then you will know the heterogeneity in behavior per country, and sort of you can maybe aggregate up or something like that and make better inferences for making policy decisions. So that's where we're going. We understand where our shortcomings are.
Can you put this in?
On the screen.
Yeah, I have one
Okay, go ahead.
graph. It's Wuhan.
Some more questions?
Wuhan Thai Hill.
Did you take into account climate
Wuhan
change
Thai
also?
Hill.
No, it's a univariate thing, but the way we sort of, the way I would account for that is just with a wide confidence interval. That's why the confidence intervals are wide, because there's other factors that really we can't just get into.
GDP is now in big question because of the inequality.
Correct.
Most of the GDPs are 20 families.
Yeah, that's why we were thinking in future work, it may be better to go to household level data with more variation in income, and you can see the difference in behavior.
To lower the credibility of Peter Timmer, you've got to...
We're not doing that.
So way down, keep going. Down, down, down.
Okay.
One thing. I think
Wuhan,
IRRI
wait,
released a
W.
study. He consider if income increases, the per capita consumption will be low. But I think many ones think that if income shift, then they can choose finer rice than coarse rice. So,
that's
so consumption may not decrease. That one thing.
better quality.
Yeah, and another thing is that rice consumption people may increase in future due to increase in population.
That's right. That's
So
what we're
that's
saying.
another thing.
That's what we're saying.
And from your result, it's just double than previous forecasting. So we should think about this also.
Well, but that's you're saying the drivers of our results already. The population, we have a fairly flat per capita consumption forecast. Okay, so fairly flat, and you add that to a higher population, and that will result in a doubling of the consumption. So you're already saying what you're sort of hypothesizing.
Okay, now, you see, Joe says that I'm always negative about everything. But the problem is that when you get to my age, you know what's wrong, but you don't know what to do about it. So I thought, well, I'll try to do something, because one of the things that's interesting is, well, we know that aggregate global data, and you've already said, maybe we should look at the country level. So, but
Household though, not types.
well, yeah, household, even the better. But you can do a household 25% quartiles and so forth like this. But I just like to see you put, the per capita consumption on top of this. But this is we can call it the Philippines and Taiwan. And you see, part of the reason I do this is because Harry at the studio was worried about Philippines yesterday, and he has a reason to be worried. But you see, because the per capita income is 10 times the size in Taiwan than it is in the Philippines, and they both started off at the same place. But that's another comment. But the point is, you're right. I mean, you have to get down to the country level, and a farm level, fine. That's a big study. And then my question to you is this: okay, you do all this. Now you're going to aggregate it. Okay, what do? You have dummy variables?
That's another question. We don't know. I don't know yet.
I'm sorry,
A
what's the
dummy by
question?
country? You have a dummy variable for each country?
What's the question?
How do we aggregate?
How do you
If we do the
aggregate?
study by
You
country?
know that the Philippines behaves differently than Taiwan, okay? And you prove that Tim is wrong because, he's assuming that everybody behaves the same way. Now, my question is, what do I do? You do all this household self-analysis, now how do you aggregate it back to the forecast?
Here's what my initial thought. So you get your household data, you estimate your income elasticities, plug in forecasts for your income and consumption, you will get aggregate per country, add it up by country, you'll get a total consumption.
Yeah.
So that's how you do it.
Sharper reflex.
Okay, are there more questions?
Anyway, it's good that you are taking on Peter Tim.
We're just pointing out some issues with it. Go ahead, David.
Yeah, I'm sorry for coming late. I normally get reminded automatically on my computer about these sorts of things, but it wasn't in my calendar, so I missed it. So I don't know if this is a question that might have been posed already. In terms of, there's going to be a relationship between your income elasticity and your own price elasticity, correct? If you look at something like the IGRM, it would show almost completely inelastic demand responses.
Yep.
Like own price elasticities on the order of 0.05.
Mm-hmm.
Almost completely inelastic demand.
Yeah.
Is this something that you would then believe based on your results?
Well, that's our implicit, again, taking the consumption as a given, that's why production tracks consumption closely at the aggregate level because of the inelasticity of demand for rice, plus sort of the storage issues as well. So if that's the case, it becomes more important then to be able to identify those parameters that determine the income elasticity. So if you go to the age type model, you automatically account for the price elasticities. If you have data for substitutes for rice and so forth, you'll have cross-price elasticities and income elasticities all at the same time. And that will be better in terms of forecasting. We didn't do that here because we're taking it as given that you're interpreting global rice consumption and you're using that for forecasting in the future.
But the bottom line is, economists are no better than weather people in forecasting the future.
That's why we have that wide here.
But I guess the question though is if we really believe that demand is that inelastic, it has very important distributional implications for what we do. Because if demand is completely inelastic, actually productivity enhancing technologies will hurt farmers to the degree that they're not self-consumers.
That's true, but again, you have to weigh the loss, the producer surplus loss with the consumer surplus gain of lower prices.
Yeah, but I just wonder because in terms of the relationship, you would expect at lower levels of income, when it's less of an inferior good, there would be a greater price elasticity magnitude, own price elasticity magnitude. As it becomes more of an inferior good, demand will become more inelastic. So you see, for example, in terms of cereal own price elasticities, countries with higher GDP, wealthier countries have more inelastic demand for cereals than.
Is that right, or is it the other way around?
No,
It's more elastic, so you have more income, right?
no, it's more inelastic. At least if you look at the ERS, they had a big project on it, and that's their general conclusion. The place where you have the highest price elasticity of demand for cereals would be the Democratic Republic of Congo, according to their analysis.
I don't know, it seems counter to what I'm thinking.
Okay. So one last question. If there's none. Okay.
Yeah, but just out of curiosity, you show us all these past studies, related to the methodology that people have been using. Has anybody, try to think of this with a non-linear type of behavior for this relationship at all?
Well, Timmer did some sort of non-parametric angle curves and so forth, but again, the problem is it's time series and it's not stationary. But I mean, is that what you're asking? I'm not sure.
Because most of those studies have viewed this as a linear kind of relationship, right? So anybody, for example, for this co-integration that nobody, you saw as many places where there's no co-integration.
Yeah.
Where that is a non-linearity type of behavior, right? But for co-integration to happen in certain bands.
In certain bands.
Yeah.
Yeah, no, I don't think anybody has done that before.
I think the returns to further model modifications are falling because of what Randy is saying, right? That
Yeah.
at some point, you got to get to the data that you
matters.
think tells you, informs the question.
I think very quickly, let's just say at some point you can have this model where you can allow this.
Yeah, sort of the threshold,
the
auto
threshold
regression.
curve, yeah.
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 There's the-
Yeah, and Joe can tell more about the star. Joe, do you think the star makes sense in this case as well, at all? The star model?
We talked about that, but there's no variable that sort of
Yeah, I don't know what
shifts the
you're,
structure.
maybe you
time
use time.
will work.
I mean, if you look at the plot of that data, it's pretty linear.
Pretty linear.
Well, but the per capita one has that leveling off. But again, it goes back to that question that Randy was saying, are we getting more information given more of this complexities or really where it has problems at the same time? Anyway, I mean, it could still be done.
Yeah, possibilities.
Yes.
Yeah.
Okay, Rod, thank you so much for your
All right, thank you
interesting
for all-
presentation. Okay.